Okay, 7.6. So we're finally using the word dilation. I've mentioned that a couple times now. Again, you might have heard the word dilation when you've ever had your eyes dilated. They put drops in your eye to make your pupils all big. And that's what dilation is. It's either making something bigger or making something smaller. So that's really what we've been talking about this whole time. But now we're using this word specifically. So 2 types of dilation, if you guys can kind of highlight a couple things in this first page of notes here. Enlargement means making something larger, right? Bigger. Or a reduction is reducing something, right? Making something smaller. So if you need to make a little note to yourself there, enlargement means bigger. Reduction means smaller. So an enlargement would be like doubling something. A reduction would be like taking half of it. Now we're going to talk about scale factor here. Again, you'll kind of see scale factor. K is the letter they use for scale factor. But it's a little bit different here than it is when we talked about scale factor before. When we talked about scale factor before, it was first over second. Scale factor in this context is going to be our primes. If you guys remember those from our last unit, they say CP prime because this is just a length of a shape, CP prime to the regular CP. So you're going to have to pay attention to which one has the prime, that goes on top. Whatever doesn't have the prime, that goes on bottom. Then this is, again, our scale factor. This is basically what we multiply with to, again, get from one shape to the next. So how we know if it's an enlargement or reduction based off the scale factor. When your scale factor is bigger than 1, again, that's what this means right here. This is greater than 1. That's an enlargement. Because I'm multiplying by something bigger than 1, I'm going to get bigger. Again, this would be like multiplying by 2, multiplying by 3. Those are all bigger than 1, and that's an enlargement. A reduction would be multiplying by a fraction that is specifically less than 1. Our scale factors can't be negative, but they'll be less than 1. So this is less than 1, however, not negative. That's what that means when we have 0 less than k less than 1. It just means less than 1, but not negative. Okay, so the questions are going to be asked are, identify the type of dilation. Is my shape getting bigger or smaller? And then find the scale factor. And then we'll apply that a little bit more in class. So let's look at number 1. It says, identify the dilation and find its scale factor. So again, this means, is it getting bigger? Is it an enlargement? Or is it a reduction? So how we know which, again, we could find the scale factor and base it off of that, but you can also look at the picture. Remember that our prime shape is our new shape. So looking at this picture, look at our not prime, that's where we started, to our p prime, that's where we ended up. Did we get smaller or did we get bigger? What do we think? Well, we started at the blue shape and we went to the red shape, right? P to p prime. What this means is this is going to be a reduction. We got smaller, right? My original shape was the blue one because there's no apostrophe on that. My prime is my new shape, and that's smaller. It's a reduction. So what this means, and when we find the scale factor k, again, that's just the variable for scale factor, we're going to put the prime on top. So now you can see there's the CP they're referencing. This is the length from C to P. It's not a part of the shape, though it can be. This is literally just if I'm dilating like towards C. Yeah, it's that length over CP. So look at the picture really quickly. What is the length from C to P prime? That's the 2. That's this right here. So therefore, the length from C to P is 3, and that's our scale factor, yeah? And again, that makes sense because our scale factor should be less than 1 since this is a reduction. What this means is my new shape is 2/3 the size of my first shape. And that's it. That's all we're going to be doing for these first couple problems. So let's go ahead once more. Look at the picture. Identify the dilation. So look at your original shape. Which one of these does not have an apostrophe, right? And which one does? Are we getting bigger or are we getting smaller? We're getting bigger. This was my original shape and I moved to P prime. That's a bigger shape. So this is called an enlargement. So when I find the scale factor k, sorry, right, SC, I need, again, my prime over my not prime. So CP prime over not prime. Look very carefully. It's an enlargement, so my answer should end up being bigger than 1. What is my prime over my not prime? Well, CP prime is this length here, right? C to P prime is 2, and CP is 1. So this is just a scale factor of 2. And again, what this means is my new size is twice what I started with. Okay, on this next one, this is a very confusing picture. I get it. You have to keep an eye out for, again, the primes and the not primes. Here's our two shapes. If you guys want to highlight them, it's two triangles. It looks like a 3D figure. What they're saying is, here are my B's. Yeah, they're kind of like drawing a line connecting B to C, A to C, all of that. It's those two shapes. So I want you to try it one more time. Look at what's your original to what's your prime. Are we getting bigger or smaller? Start there. Go ahead and actually answer that first. Where's my original? Where's my prime? Are we getting bigger or smaller? We are getting bigger. There's the primes. This is an enlargement because my primes are a larger shape. So your scale factor needs to, again, be the prime over the not prime. Now, in this one, notice P is no longer a thing. But that's okay. We just need a length to our prime shape over not prime. If P and C are not there, you just think that way. What's a length to the prime over the length to the not prime? So go ahead and take a look. We have 7 and 3. Which of these goes to the prime? And which one goes to the regular? Well, looking at this here, 7 is the length to the prime, that's 7. And then 3 is the length to the not prime. Oops, sorry, I highlighted that wrong. 3 is this length right here. So this is the prime to the not prime. So it should be 7 over 3. And again, that's good. That would be bigger than 1. That is an enlargement. So we're going to keep working with this in class. I just wanted you guys to practice these two basic concepts first. We'll keep going on about how to use this from